Let us now discuss electrochemical cells or galvanic cells. You know, electrochemical cells or galvanic cells are based on the spontaneous redox reaction. Now here I would like to tell you that the redox reaction can take place directly or indirectly. Let us first consider what happens if the redox reaction takes place directly, or direct redox reaction. Direct redox reaction. Direct redox reaction means that oxidation and reduction take place in the same container. So let us suppose that we have taken here copper sulfate solution. This is a copper sulfate CuSO4 solution. Copper sulfate solution is blue in color. Let us suppose that in this we put a zinc rod. When the zinc rod is put in copper sulfate solution, then we observe certain things. Number one, that the zinc rod loses its weight. As you can see, that zinc rod get dissolved. Number two, that the color of copper sulfate solution fades. Copper sulfate solution is an intense blue colored solution. So when you put zinc rod, then the color of copper sulfate solution fades. Then the copper is deposited here. And the most important thing which I want to stress here is that the temperature of the solution is increased, or this solution becomes very hot. How do you explain? How can you explain all these observations? So we say that this is an example of a direct redox reaction. So we have taken copper sulfate solution, CuSO4, and then you add zinc solid rod. This zinc is converted to ZnSO4 solution, AQ, plus Cu solid. So zinc, since zinc solid, zinc rod dissolves, therefore it is converted to, therefore it loses its weight. Copper sulfate solution is colored due to the presence of Cu2 plus, and since Cu2 plus ions are removed as copper metal, therefore the color of copper sulfate solution fades. And the most important thing, that the chemical energy of this redox reaction is now manifested in the form of heat. So the chemical energy of the redox reaction right now in this direct redox reaction is converted into heat energy, and the overall reaction is you can see Cu2 plus from copper sulfate. When zinc is added, then you get the Zn2 plus Cu solid and heat. This solution becomes very hot. So the chemical energy is converted into heat energy. Now if the same redox reaction is allowed to take place in two different containers or indirectly, then this chemical energy, which is right now converted into heat, will be converted into electrical energy, and that becomes the source of electrochemical cell. So what is electrochemical cell? So the electrochemical cell is a device. The devices in which the chemical energy of the spontaneous redox reaction is converted into electrical energy are called electrochemical cell or galvanic cell. So you must understand that electrochemical cells are based on spontaneous redox reaction, and the chemical energy of this redox reaction are converted into electrical energy. Now, an electrochemical cell was prepared for the first time independently by L. Galvani in 1780 and Alessandro Volta in 1800. These are therefore called the galvanic cell or voltaic cell. Now the simplest galvanic cell is a Daniell cell. Now we are going to discuss the working of the electrochemical cell. The same reaction which I have taken for the direct redox reaction is now taken to construct the electrochemical cell. Now in this case, the two beakers are taken. In one beaker, 1 molar zinc sulfate is taken and zinc rod is dipped in zinc sulfate solution. So this is a zinc rod dipped in 1 molar zinc sulfate solution. Then in another beaker, copper sulfate solution is taken, and here the copper rod is dipped in this copper sulfate solution. This is a copper rod, and here we have taken 1 molar CuSO4 solution, 1 molar copper sulfate solution. The two rods are connected by a conducting wire through a key and through an ammeter. This ammeter indicates the flow of current. Now this zinc is anode. It is a negative terminal, but it is anode. Please remember, the negative and positive sign has nothing to do with the anode and cathode. This is a positive but cathode. This is the point where many of the students get confused. I just want to tell you that anode is not the electrode where the negative charge is accumulated. Anode is the electrode where oxidation takes place. So this definition is valid both in electrochemical cell as well as an electrolytic cell. So remember, anode is not identified as negative. Anode is the electrode where oxidation takes place, and cathode is the electrode where reduction takes place. Now why it is negative, that is altogether a separate issue, because this electrode is rich in electron. Electrons are accumulated on this electrode, that is why it is taken as negative. And this is electron deficient electrode, that is why it is taken positive. So zinc rod is dipped in zinc sulfate, copper rod is dipped in copper sulfate solution. The two rods, which are called electrodes, are connected by a conducting wire through a key. This is a key, and then this is an ammeter which indicates the flow of current. And now electrons flow from zinc to copper, and conventional current flows in the opposite direction. Current flows in opposite direction. Now the two solutions are connected by an inverted U tube, which is filled with the inert electrolyte in a semi-solid form, and this is called salt bridge. Salt bridge. This salt bridge contains KCl, K2SO4. It can contain KCl, K2SO4, NH4, NO3, etc. in the semi-solid form, such as agar or gel form. The U tube which connects the two glass rods is called the salt bridge. I have already told you. The two openings of the salt bridge are plugged with some porous material such as a glass wool or cotton, so that these ions do not mix. So this is the construction. This is the construction of the galvanic cell. Now let us see.